Hi, in this video, I'm presenting about comparing two means, more than two means, and two variants. These are your learning objective. Number 1, test the difference between two means using the z-test. Number 2, test the difference between two means of independent samples using the t-test. Number 3, test the difference between two means of dependent samples using the t-test. Number 4, test the difference for more than two means using ANOVA and f-test. And number 5, test the difference between two variants using the f-test. In this video also, I'm going to teach some of the basic skills of using Microsoft Excel for the 5 tests that I have mentioned just now. Before we start, make sure your Microsoft Excel has the data analysis tool pack. If not, then please watch this step-by-step installation of the data analysis tool pack in Microsoft Excel. In this section, we are using the traditional method for comparing two means. These are the 5 important steps for the test on the difference between two means. In step 1, we define the hypothesis. Remember that there are 3 types of tests to be considered and can be determined based on the problem to be answered. For step 2 and 3, the values can be obtained by using Microsoft Excel. In next slide, I will show you the step-by-step process on how to use the data analysis toolpack on calculating the critical and test values. After we obtain the output from the Microsoft Excel, then you can make your decision depending on this table. After that, you can write the summary for the problem. Objective number 1. Test the difference between two means using the z-test. Before we conduct z-test to determine the difference between two means, make sure we obey some of the assumptions, such as both samples are random, the samples must be independent, and then the standard deviation of both populations must be known, and if the sample size are less than 30, the populations must be normally or approximately normally distributed. Now, let us see on example 1. Test the claim that the two population means are equal using the sample data provided based on this table at alpha equals to 0.05. Assume that the population variance are for A 10.067, for B 7.067. From this example, we can write the hypothesis like this. Then, by using this data, we can calculate the critical and test value as follows. Objective number 2. Test the difference between two means of independent samples using the t-test. These are the assumptions for the t-test. Number 1, make sure the samples are random. Number 2, the sample data are independent of one another. Number 3, when the sample size is less than 30, the population must be normally or approximately normally distributed. Example 2. Test the claim that there is no difference between population means based on this sample data. Assume the population variance are not equal. Use alpha equals to 0.05. Similarly, we write the hypothesis like this, and then by using this data, we can use the Microsoft Excel to find the critical and test value before we make our decision and summary. Objective number 3. Test the difference between two means of dependent samples using t-test. The assumptions is similar as the objective number 2. Now, refer to example 3. Test the claim that there is no difference between population means based on this sample pair data, and the alpha is 0.05. So similar to the example 2 and 1, we have this hypothesis, and by using this data, we can use the tool pack just now to find the critical and test value and make the decision. Based on the first until the third objective, we can come up with some explanation. By referring to this figure, when the null hypothesis is not rejected, that means the difference between sample 1 and sample 2 is not significant. The means for sample 1 and sample 2 can be said that come from the same population. So, what if we reject the null hypothesis? That means the difference is significant. The means of the population are different. In the other word, the sample mean 1 come from the population 1. On the other hand, the sample mean 2 come from the population 2. In this section, we continue with the traditional method for comparing more than two means. These are the 5 important steps, and the steps are similar when we comparing two means, except for the hypothesis, we need to mention for the h sub 0, the mean 1 equal to mean 2 equals to mean 3, and then for h sub 1, we just have to write that at least one mean is different from the other. Objective number 4. Test the difference for more than two means using ANOVA and f-test. These are the assumptions for the f-test. Number 1. The population from which the sample were obtained must be normally or approximately normally distributed. Number 2, the samples must be independent of one another. Number 3, the variance of the population must be equal. And lastly, the sample must be simple random and one from each of the population. Let us look at example 4. Test the claim that at least one mean is different from the others based on 3 sample data. The alpha is 0.05. Based on this example 4, we write the hypothesis like this, and then we copy this data and use Microsoft Excel to test the claim. In this section, I'm going to explain the traditional method for comparing two variants. These are the 5 important steps for comparing two variants, and then make sure you follow this notation for the hypothesis. Objective number 5. Test the difference between two variants using the F-test. These are the assumptions for testing the difference between two variants. Number 1, the sample must be random. Number 2, must be normally distributed. And number 3, the samples must be independent of one another. Example 5. The CEO of an airport hypothesized that the variance in the number of passengers for Malaysian airports is greater than the variance in the number of passengers for foreign airports. At alpha equals to 0.10, is there enough evidence to support the hypothesis? The data in millions of passengers per year are shown for selected airports. So from this example, we can write the hypothesis like this, and we refer to this table for our data analysis using Microsoft Excel. Thank you.